Normally when I give these talks, it's an audience full of techies. So having this diverse audience is really nice. I won't get needled, hopefully, on every single technical point that I make. So it'll be very comfortable. And I'm really privileged to be here today, and I appreciate TFI for giving me this opportunity. So some disclosures before we begin. As Larry mentioned, I'm from PHAZR. I'm a co-founder at PHAZR, and we were just recently acquired by JMA Wireless. And so you're going to see a lot of products in our portfolio. But the good thing is, our products are representative of the state of the art in the 5G industry. So, whatever I'm showing you here should be representative of what you're going to see from the other vendors as well. I'm only going to show base station and customer premise equipment technology. So here you see the base station technology and the customer premise equipment technology. No handset technology. This doesn't mean you can't use your cell phones. It just means that I'm not going to talk about handset technology. It's coming, but don't expect it to look too much different than the cell phones that you already see. The form factor for the cell phones is not necessarily going to be driven by the 5G millimeter wave antennas or anything like that. It's going to be driven by other requirements. So you shouldn't expect to see too much different on that front. But as far as the base station and the customer premise equipment, as Ian mentioned, customer premise equipment services the fixed wireless access users. So that will be getting really high-speed internet wireless to your home. Okay, so some preliminary things to consider just to set the stage for how the look and feel of our products is. So Ian mentioned several of these things, but I'll go over them. Hopefully, after this slide, we'll all be kind of on the same page so that when I go over the product form factor, it'll all make sense to everyone. So let's talk about densification. So generally speaking, and this is general, there are caveats to everything, but generally speaking, base stations offer a certain amount of capacity. And that capacity is a function of whatever technology we're using. So of course, for 5G, we're extending technology, we're creating technology advancements, and that will enable the base stations to have more capacity, so it'll provide more data rate to all the users that it services. But the expected user demand is going to outpace the technology advancements we could make in the base stations. So as a consequence, what we expect to see, and you saw this in Ian's presentation as well, is that instead of being able to pack more and more data rate into each base station, the base station coverage is going to be less. And so therefore, there's going to be less users assigned to each base station and more data rate per user. So that's one way to get around the problem. It's not necessarily a problem, it's just that the consumer demand is going to outpace what the technology can provide on a per link basis. Another thing to consider is massive MIMO. So you probably hear a lot about antennas for 5G. And there's a couple reasons for that. One, when we use millimeter wave, these really high frequency radio waves where there's tons of bandwidth available so we can push tons of data over the links, the fundamental frequency, the spectrum frequency of these radio transmissions is a very high frequency. So the consequence of that is that the antennas are very, very small. There are negative aspects of that, but there are also positive aspects of that. And the positive aspect of that is that we can throw tons of antennas on these base stations, on these user equipment. And by doing that, we enable very, very directional communication. So we can essentially point the communication in the directions that we want. And that changes a little bit how you can design your base stations. So no longer do you have to expect that your coverage is going to be in let's say, 120-degree sector or a 60-degree sector. Now you can narrow down and expect to be able to deliver your signal to a very, very focused area. And that's good for interference. So that helps your performance. And then the final thing I want to talk about is edge computing. So building upon densification and building on the extension of capacity, we know that we're going to have to basically support these really, really massive bandwidths to each of the base stations. Well, the problem with that is, given the current way that the base stations are architected, so the way the current base stations are architected is there's two basic sets of equipment. There's a set of equipment that's up on the tower, and there's a set of equipment that's on the ground. The set of equipment on the tower is analog. roughly, not exactly, but just think of it as analog technology. And then there's digital technology in the ground. And then we have some transport from the digital to the analog technology. Well, that transport gets very, very difficult as the bandwidth that's provided by these base stations grows. Also, Ian mentioned this also a lot, if we want really, really low latency links, we need to be able to do the processing very quickly. We need to have that processing as close as possible to the base stations. So the real innovation that we're going to see in a lot of these base stations that come for 5G is that no longer do you have this separation where you have this equipment on the ground and this equipment on the tower. Everything can be joined together. Now, that sounds like an obvious thing, but it's not so easy to achieve that. So a little bit of self-promotion here. PHAZR was a startup. We recently were acquired by JMA, which is a mid-size supplier for the telecom industry in the United States. And really, we feel like we are in the right position to be a disruptor in this industry. There's been vendor lock-in too long. There's a closed architecture for the system. It's very hard for the incumbents to be taken out, for their equipment to be extracted from the system, because up until this time, technologies have been sort of gradually evolutionary. But the 5G is a huge departure. As you saw from Ian's presentation, the system architecture is completely changing. You have these smaller cells, you have this heterogeneous network. From all this upheaval allows us to have opportunity to come in and compete in the marketplace. Okay, so what you guys are really here for, let's talk about the products. So these are the products that we have publicly disclosed. So 4 products are what we call a Rayback. So that's a 3-sector base station. If you remember, I was saying that with millimeter wave and massive MIMO technology, we can really focus the signals in strict directions. But one of the aspects, one of the consequences of that is that our base station now can not only service a single 120-degree sector, but we can have our sectors shrink. So this base station that you see here actually takes the normal 120-degree sector layout, and it breaks it down into 3 subsectors. So essentially, even without the advanced technologies, you get a 3x capacity increase. This is our customer premise equipment. I have one actually sitting here. So if you want, after the talk, we can take a look and feel at that. But basically, this customer premise equipment will sit in your home. It will be pointed roughly in the right direction of the base station. This isn't as sensitive as, say, a satellite dish, where you have to be laser focused on the link so that you can make sure that the link is connected correctly. Or I should say, or backhaul links, which are very, very tightly organized. But essentially, it's pointing in a general direction of the base station, and this allows you to get gigabit per second access to the wireless network, or to the internet. And then 2 other products. These are new products. And these products really build on that densification aspect of 5G. As I mentioned, because the network is densifying and shrinking, you can imagine that, okay, so in the past when you did deployments with base stations, you had to get, you have to make sure that you can get at least for the site. There's a lot of regulation around where you can put those base stations. And it's not easy to find sites. Even though you might want to put a base station here, it might not actually be possible for you to do that. So now that we're shrinking the cells and making them smaller and making more of them, you can imagine that problem is even going to be more difficult. So as a consequence of that, we have to be a lot more creative in how we deploy these things. So in particular, our street RAN system can be mounted on a strand on the pole mount. So on the cables that run across the poles in your neighborhood. So the same way that your cable technology is deployed, the nodes are deployed, and your cable network, your 5G base stations can be deployed as well. And lastly, before I get into the real pictures, the fun, let's just take a look at the interfaces. There's nothing groundbreaking here, right? But you can see that these things are mounted, and there's only really the need for power and your backhaul connection. That's it. So there's nothing really new from that perspective that you're going to see in the 5G technology.
But a remote radio head, is that required?
Well, that would depend on if it's a macro cell or a small cell. Small cells, it's going to be tougher to have a remote, like a electronic tilt or something like that. If you're talking about the remote radio head, that's kind of talking about the split between the analog and the digital processing I was talking about. So everything is integrated into a single system in these products. The remote radio head with the baseband processing, it's all together. So there's new products. We recently debuted these new products at a trade show here in Austin. So you can see the size of these units are not too big. This is the base station, the three-sector 120-degree base station, and the 90-degree street RAN you can see. And this is just normal size. Now, these things are going to be going in neighborhoods and in a lot of municipalities, and you can imagine that there's a little bit of where are you going to put these things, make sure that you get enough coverage. So we've made our mounting system very flexible so that we can mount in basically any kind of environment. Here you can also see the cable-mounted strand. We have 2 trials ongoing right now with friendly customers, one in the US and one in the UK. This is similar to what Ian was talking about with Verizon in Houston, although we're using a little bit different technology. So here you can see our 5G base stations on the tower, and here is another site. So you can see the scale of them. They're not too big, but they're not too much different than you would expect from a base station. And here you can see the CPEs deployed in homes. So all of these homes are being supplied with PHAZR internet. And the speeds that we typically see are similar to what Ian was saying, so somewhere between. Go ahead.
I have a question. You said you have those 3 120.
Yeah.
Then this new, you take that 120 and have 120 devices that each take care of 1 degree?
Not 1 degree. So within that 120 degrees, there are three mini sectors, essentially. So each one of those 40-degree sectors services a set of users independently. They also coordinate together, but that's the general idea. So you take a 120-degree sector, and you're literally multiplying it by 3. And because of the spatial focusing that we can do with this antenna technology, we get that capacity for free. We don't have to trade off anything.
Talking about gigabit speeds, what more is it?
Yeah, so it depends, right? So there's a lot of factors that go into this. How much foliage coverage you have, how line of sight you are. You don't have to be line of sight, but you want to be if you can be. So it's anywhere from 100 to a gigabit per second. And of course, range as well, depends. And here is our UK deployment. So you can see our base station in the midst of other remote antennas, or I should say remote radio heads, and backhaul systems, and kind of fits in. There's not too much from a look and feel perspective that's different other than those 3 faces that I mentioned earlier. And again, here we have our CPE deployments. You can see that we have different mounting strategies. Here, actually, we're using a pipe mount fixed to the side of a building, but we also have a building mount where you can mount it directly on the side of the building. And I can go back through this person, but any questions? We can go back through the pictures.
What does are hanging on the cable?
Yes.
Okay. How do you get the power there?
Yeah, so it's a good question, right? But there is power available. I don't want to get too much into the detail of the power that we're using, the connector that we're using, but yeah, there is power available, just like there is with the cable deployments that we can take advantage of. And we have to make sure that we're below a certain number of watts in order to take advantage of that.
But you get the power out of the phone.
Yeah.
So as we look forward, is virtually everything up on the tower except the power?
That's our
source,
vision, right?
The
Our
power
vision,
source and the transport is the only thing that's down on the ground, right?
Yeah, the backhaul and the power, and that's it. That's our vision. If you really want to take advantage of this densification of the network, you have to go that direction.